Okay, remember way back in chapter 3, we talked about even functions and odd functions. I think this, you might not even remember this. It was a tiny little detail in one of the sections in chapter 3, and we didn't do much with it. But back in chapter 2, when we were talking about equations in general, I did talk about symmetries of equations. You might remember on a previous worksheet, there were there was problems where we were trying to figure out if the graph of an equation was going to be symmetrical over the y-axis or over the x-axis or over the origin. Well, that's related to this idea of even and odd functions. An even f of x is one that satisfies f of negative x equals f of positive x, which is basically symmetry over the y-axis. So like a vertical parabola centered on the y-axis would be an example of that. That's even. An odd function is one that satisfies f of negative x equals negative f of x. This is basically symmetry over the origin. So draw that line through the origin, and then you reflect it over that point. So even and odd. Now it turns out that all trig functions fall into either even or odd. So we can divide them up into categories. So let's look at a unit circle. We're gonna explain the even and the odd properties of the trig functions by looking at the unit circle. Let's say you have a positive angle t. Okay, there's t. That terminates at a point up here, x comma y. Now, if you look at negative t, which would be down here, the point down here is going to be a reflection across the x-axis. I didn't draw my picture perfectly, but it's pretty close. It's a reflection across the x-axis. So the coordinates at this point down here should be the same exact x-coordinate, but the opposite y-coordinate. So what this means, this is negative t. What this means is that cosine of negative t is this x value, which is the same as this x value, which is the cosine of positive t. So cosine is even. And then sine of negative t is this y-coordinate, which is the opposite of that y-coordinate, right? It's the negative sine of positive t. Right? The fact that these y's are opposite means sine of negative t equals negative sine of t. So sine is odd. Cosine is even and sine is odd. So there's our first piece of useful information. Okay? Then combine that with all the reciprocal and the quotient identities we learned. So take, for example, secant. Let's see what secant of negative t is. Secant of negative t is 1 over cosine of negative t. Since cosine is even, it's 1 over cosine of positive t, which is equal to secant of positive t. So this shows secant is even. Let's start divvying these up into categories here. We've got cosine in the even side and sine in the odd side. This here shows that secant is also in the even side, which makes sense if it's just the reciprocal of cosine. Cosecant, since it's just the reciprocal of sine, is going to be on the odd side. You can prove that for yourself in a very similar way. Next, let's look at tangent. Tangent of negative t, the quotient identity says that tangent is sine over cosine. So if we're putting negative t into the tangent function, we've got to put negative t into sine and negative t into cosine, like that. Now, since sine is odd, the numerator here is negative sine of positive t. And since cosine is even, the denominator is positive cosine of positive t. Now, sine over cosine is tangent, and this is t, and so this is negative tangent of t. So starting here and getting here shows us that tangent is also odd. And similarly, you can do the same type of thing with cotangent to show that it is odd. So here's the results. The results are in, and here's how it ended up. It's even 2 to 1 or 2 to 4, even to odd. So odd wins by a huge margin. There's two trig functions are even and 4 trig functions which are odd. So yeah, so there we go. That's all I wanted to say in this video. This is a little piece of information about trig functions, which comes in handy every now and then. And when we in the next chapter, when we eventually get to talking about equations and functions and their graphs, then for graphs, we're going to see the symmetry we talked about, like this symmetry kind of ideas. We're going to see this play out in the graphs of these functions. So I'll mention this again later.